and this also in, both are in first excited state and this is at rest. After collision, the hydrogen atom is found to be in ground state, whereas this will get excited. Are both in their first excited state. Lithium ion in its second excited state. So shall I put n equal to 3? If I write minimum velocity, shall we do like this? Minimum velocity of the moving hydrogen atom. For any velocity, no. There's some velocity less than that, not possible. So what should I do now? Any other velocity possible. Hydrogen atom can come to ground state and they will move with a different velocity. So therefore, though it didn't mention, think for minimum velocity only. Straight away, can we use that formula? Like yesterday we did, no? The kinetic energy of incident particle is equal to excitation energy plus 1 plus mass of incident particle plus mass of target. What is the excitation energy altogether? There's a one method. I'll keep this aside. Sometimes what happens, they may not ask you that minimum. So every time you cannot use. So when to use this one? When it says minimum, anyway, like it said only velocity. So still can I use? Yes, you can apply, no problem here. Sometimes intentionally will say that after collision what happens, they don't move combinedly. Then you cannot use this formula. Because when the incident kinetic energy is minimum, what will happen? Then it will be perfect inelastic collision occur. When the incident kinetic energy is greater than K minimum, then inelastic collision will occur here. Okay, fine, this one. So directly you have to calculate delta E, that's all. Or else another approach. There's another approach. So what is the energy here? Energy in the second excited state. So for hydrogen, there's a hydrogen atom, E0 I'll call it. Energy in the first excited state plus kinetic energy of this one, mhu square by 2. Now what is the energy of this? I think hydrogen 1, I'll write it, n equal to EH2, I'll write it. Lithium, energy in the first excited state, and it is at rest, no? Equal to, finally, the hydrogen atom is having in the ground state, how much? Minus 13.6 electron volt, plus it's having kinetic energy, mh square by 2, ml, or together, we'll write it here. Then applying conservation of linear momentum, mhu equal to mh plus ml into v. Substitute all this energy of the hydrogen in the first excited state, you know value, that of this. Substitute the specific values and solve it, you'll get the required answer. If you're unable to exactly make a guess of delta E, I think that negative sign you have to take care here. And mass of hydrogen, mass of lithium double plus is 7 times of that. So you can replace mh and ml here. So solve this, we'll get around 3.9 into. Sir, if it says minimum also, shall I use this formula? Yes, this is a generalized one. Huh? Now, if it is the incident particle hydrogen, if it is coming with energy greater than K minimum, can I use this formula? Yes, you can use. In that case, you show different velocities for hydrogen and lithium. But this is applicable when? Only when the incident particle comes with minimum kinetic energy. I just wanted to introduce you both the ideas. This is strictly applicable for when it is incident at minimum kinetic energy. This method is applicable for generalized case. Let water be that. Since it didn't mention, I'm going for minimum because I should search for minimum. What is the minimum possible velocity? So both are applicable now.